Okay, hello everybody. How is everybody doing today? I hope everybody is doing really well. Good afternoon / evening to everyone. How's everybody doing? Turn that down just a smidge there, and then we should be okay. Hey, there we go. We are here for Math 102 at 4 o'clock. Well, hopefully everybody is doing absolutely fantastic. Good evening to you, Hisa. How are you this evening? How are you this evening, Hisa? Hopefully you're doing well. Hopefully getting all ready for the weekend here. You just got one more thing to go, and then, there you go. As simple as that. Yeah, I'm doing pretty good, Got a few things I'll need to take care of this weekend, but once I do, should be okay. Little bit of cleaning, little bit of organization, and a few emails to send here and there. That should be alright. At least I hope I can do it. Question mark. Like, maybe I can, maybe I can't. Sure, there. Alright. We'll see how things go. Hopefully you're all ready for today. Today will be a nice, I don't know. I think today will be a pretty easy, relaxing day. I don't think it'll be that hard to do. I think we'll be able to get out of here a little bit earlier. And I think that's possible. I don't think that should be too bad. Let me see here. Yeah. It should be pretty easy. Well, I don't have a choice, do I? Well, you do have a choice. I never said you didn't have a choice in this class. You had the choice of not even showing up, and you showed up. I enforced that choice. I'd be like, alright, you decide to show up, and I just tell you what the expectations are of what possibly will happen today, and then we just kind of run with that. And then magic things happen, and then, you know, stuff happens, and other bitty bobbity boos, and then, you know, suddenly we're done. And then that happens. Well, if I want to, I mean, hey, look, it's also a personal choice. I mean, I told you I'm not here to play gatekeeper to your graduation. Trust me on that. Alright? The only person who gets to decide that is not me. I think you know who gets to decide that at the end of the day, and that's you. So, now do I want you to get to that graduation level? Absolutely 1000%. Alright? I just, you know, yeah, as a professor, teacher, whatever you want to call me, you know, I put a little box of choices in front of you after you've paid me to do so. You paid me to give you choices. Here are the choices. Now you get to choose. Alright. I think we're gonna get ready here to get moving in just a second. Well, that's why I don't have a choice, else I'm gonna waste my money. Well, yeah. I don't disagree with that. Some people will go down that path. I know that for a fact. Some people many times over have decided to to go down that path. I mean, heck, I went down that path once. Is like, you know, sometimes you have to. I don't know what it is. I think I know what it is. Maybe it's like it's how we view our own money and how we view someone else's money. So like, if your parents pay for it, it's like it's someone else's money. You don't care for much as it is. But if it's your own money, you're like, oh, I better not let this go to waste. Otherwise, I'm really dead meat. You know, I'm not taking advantage of what I'm given. You know, so it's kind of like that that kind of psychology, I suppose. Because I don't want to waste my time and money, especially if it's your own money. You're like, oh, even if it's on a scholarship, you know, or not scholarship, even if it's on financial aid, you're like, oh, you know, no, I totally understand. But if it's like financial aid, for example, you're like, oh, well, I gotta pay back that money someday. So it's kind of like your own money. You know what I'm saying? And then you're like, some people take the proper choice, like, okay, it's my money. I have to be careful about it because I gotta pay it back, and I can't get out of it. So it's like, all right, that makes sense. That's how I kind of viewed it. You know, my first year and a half was pretty ugly. So I'm like, and then I had to understand that, yeah, you know what, I gotta be responsible with what I'm doing, 100%. All right, ladies and gentlemen, I think we're about ready to get going here. Let's do some introductions. And let's do the intro, and let's get going. All right, let's do this. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, today we are going to be finishing up Chapter 8. Yes, there are only 2 sections in Chapter 8. Last time we did talk about how to do stuff here underneath the normal distribution, and again we did normal CDF, we did inverse norm. We just did those two things. We just made one minor change here to the standard deviation, and bada bing, bada boom, we found ourselves a winner. Alright, let me grab a piece of here. My nose is running. I don't even know why. Wait. Running. What? Alright. I don't know why. Alright, anyway. So, today we're going to be looking at another different perspective. Now, if you're the only one here today, then it is what it is. So, I don't mind teaching one person or 100 people. Either way, I'll pretty much do the same lecture, so... but I'll just tailor it to you. Alright. So today, ladies and gentlemen, we are going to be covering a slightly different topic here. We're still going to be using Normalcdf. We're still going to be using inverse norm, the same exact things here, only with a slightly different perspective. So let's go to the big board here. Alright, let's see what we're talking about. Let's do it. Big board time. Okay. So I'm going to put this here on the left. Alright. So today we're going to be doing the latter half of the last handout here from on Tuesday, and that's we're going to start here on question number 4 here, as you can see here on the screen. Alright, so let's go ahead and talk about question number 4 here. See, Pistache is here, there you go. It just took a while for Pistache to come online, that's all. Why, I don't know, but it just took a while for Pistache. That's all. Bring that down just... Okay. I was here, F4, just silent. Ooh. The silent type, I see. I respect that. Alright. So let's take a look at number 4 here. Today we're going to be looking at not sampling distribution, not like we talked about here last time, but today we're looking at proportions, okay? So this is going to be very valid for things like the surveys that we normally like to do here. So we're looking at proportions here. Now, there's going to be a little bit of a notation here that we're going to have to kind of get used to here. So how do we find sample proportion, population proportion? So we have this letter P here, which is called population proportion. Now note, I want you to make note here of this notation because it does interchange quite a bit in the book, and we have to note the difference between P and P hat, okay? So I do want to make note of that. That way things are not confusing, okay? Because at times, if you're not sure what means what, then it can be very confusing very quickly. So P here is what we call the population proportion, okay? So it's like if we look at the whole country, if we look at the country as a whole, or whatever, the population as a whole, whatever the case may be, then we would have a good idea about what, you know, the population as a whole thinks about something. All right? Now, P hat, on the other hand, is the sample proportion. So this is basically the actual, think of it this way, like the raw data that we're given here. So as you can see here, that's going to be equal to X over N, where X is the number of people who said, say, quote unquote, yes to our question, and N is the sample size. So, for example here, I ask you, hey, you know, I'm taking a survey. Do you like brand A? Okay, you will say yes or no to that question of if you like brand A. Maybe I ask 500 people. Maybe I ask 1,000 people. Maybe I ask you maybe more than that. Whatever the case may be. Again, and then I mark down how many people said yes to my particular question if they liked brand A. And then there you go. That's going to be my sample proportion. Remember, our goal here is to, of course, take this data and hopefully extrapolate that to the entirety of the population. So we're looking at here just kind of like, right now, kind of in a mini box. But again, be able to kind of extrapolate that to a population to some degree for this section. All right. So let's take a look at number 5. All right, so if we're going to talk about the nitty-gritty details here for what we are going to specifically look at here in comparison to the last section, well, it's certainly number 5 is certainly one of the differences here. It says, what is the standard deviation of a sample proportion? What is the standard deviation of a sample proportion? So if you recall last time, we looked at the standard deviation. We switched the standard deviation on the Normalcdf function, and that's where we're able to find that guy. In this case, for proportions, we're once again going to change our standard deviation using this formula here. It says rho of p hat, again, is equal to the square root of p times 1 minus p, all divided by the sample size, which is n. All right, so the standard deviation for a sample proportion, again, square root of the population proportion times 1 minus the population proportion divided by the sample size. And notice this is all underneath the same square root. So do keep that in mind here. Now, why is this important? Well, of course, we're going to be using it with our Normalcdf and inverse norm functions, but we also have the other added ability here. So I want to talk about this here really quick. So, all right. And that talks about, well, if we're talking about sample proportions here, say again, some random survey that we ask a yes or no question about, we also have a central limit theorem of proportions. So what is a central limit theorem for proportions? So here's what it says. It says the larger n gets, the more the sample proportion will resemble a normal distribution. So of course, if we have a big N, if I ask 500 people this question, do you like brand A? Well, it's going to look like a more and more of a normal distribution, okay? That's very important. It's going to look more like a bell-shaped curve than maybe it looks like anything else. So what does that mean here in this case? Essentially, we can go ahead and use our Normalcdf and use our inverse norm here functions, and we can justify that so long as we can ask enough people this question and be able to get an answer for it here at the end of the day. Now, it is contingent on a few things. We need to be sure that we ask enough people. How do we know we ask enough people? Well, you take a look here on this first part here. It says it's contingent on, first and foremost, that if we take the sample size and multiply it by p times 1 minus p, that has to be bigger than or equal to 10. So again, we can't just ask 10 people a question and assume that that's going to be satisfactory to the rest of the population. No. We're going to certainly take n here, the sample size, times p, times 1 minus p, and we'll make sure that's bigger than or equal to 10. Now, we can also gain two more conclusions based off of this. All right? So our two conclusions can be this. All right? First of all, the mean for the sample proportion will equal the population proportion. So we're going to make the assumption here that the mean that we're going to be using here underneath our Normalcdf, or our inverse norm functions, is going to be equal to the population proportion. So let's just make an assumption here. It says, okay, whatever the sample is, it should match what the population is. So we're just going to make that assumption. And then make the adjustment here for the standard deviation, which is the square root of p times 1 minus p divided by n. Fine. Okay. Now, that's a lot of talking. Understandable. Let's go ahead and take a look at an example, and let's put actual numbers to the actual concept itself. All right. So we are going to do number 17. So let's do that. I wrote it down, but let's do it anyway. It's on page 385. Got the book for this. Okay. Let's look at 17. We'll do this one here together. And, well, it'll help me out, of course, and we'll see exactly what we're doing here. All right, so let's do this. According to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. All right, let's start off with letter B here. What is the probability that in a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? So we are given a sample size here of 500. We're trying to find the probability that less than 38% believe that marriage is obsolete. Actually, that's a good question. Guess I'll ask you guys here really quick. Let's put up a poll. Let's put up a poll. Is marriage obsolete? Let's do our own little poll here. Do you think marriage is obsolete? Yes or no? Put a poll up there in the chat. Go ahead and mark if you think marriage is obsolete. I think it's not. Hey, Yusuf, how are you, my friend? Good afternoon / evening to you. Go ahead and put that in the chat. If you think marriage is obsolete. This is actually one of the most interesting questions in the book. Do you think marriage is worth it? Or is it an outdated concept that really isn't worth anything anymore? You know, it's a very, like I said, very interesting question. Okay, so we got 5 people said no, marriage is not obsolete. One person said yes, it is obsolete. Now let me ask this question here. You guys can post your answers in the chat for this one. Do you think, with the current trends, the way things are, do you think it's necessary for you to get married? Do you think it's necessary for you to get married? Hisa says no. Okay. Nah. Okay. Okay. So let's work off of that. All right, let's work off of that. It says, okay, may not be necessary for you to get married. Now, the question becomes, let's talk about your personal preference here. Would you like to get married in the future? Is that something that you see yourself doing on a personal level? Yes. Okay, yes. No. Okay. Yes. Yes. All right. Got a lot of good debate regarding this question here. It's a very interesting question because it's kind of like a personal question, but at the same time, you look at it from a societal point of view as well. So, yeah, some people here definitely would like to get married sometime in the future. And some people said, no. Julian's like, no, I don't want to get married. And of course, that's just perfectly fine too. I don't have a problem with that whatsoever. And let me ask you this, at the very least, all right? Um, now think of it this way. We have companionship and whatnot, and I think that's important for some people. For others that may not be as important of a thing. But let's ask. When I was I guess I'll ask it this way. When I was in Japan, having a getting married was something that you did later and later because maybe you have for many people, they're trying to establish their independence. They're trying to be financially independent. And having someone else with you is, again, kind of like another financial undertaking. Sometimes even being in a relationship can be another financial undertaking. So, it does take time and it does take energy. And for some people, they're like, well, I just don't want to get married because I don't feel like I'll be financially independent. And some people don't even opt for children because it's, too much financially for them to take care of in a lot of ways. Actually, that's another good question here. Would you like to have kids? Some people, a lot of couples, even people who would like to get married, some couples said, no, I don't want any kids because it could be too much to take on. Now let me ask that question here. Do you guys, in the future, let's say, in the future, would you want to have children in the future? Would you like to start a family? What do you guys think? Yes? Okay. No? Okay. Everybody's got a personal preference about, even kids. Chimpin says yes. Okay. Fair. Yes, okay. Now it's the most interesting part of this question here is like, if you get down to the point, like, I know most of you guys want to get married. Maybe some of you said, I don't want kids. Some of you said, yes, I want children. I said, I respect either choice. I don't have a problem with either case, okay? You guys are perfectly fine respecting that. I've just noticed the trend here, at least in the United States, it's becoming more and more like Japan, where people are maybe not opting to have like a committed relationship, but maybe they're more opting to have a dating app or something like that to have, say, a boyfriend or girlfriend, and maybe they get married to that person in the future. Maybe that's something there. But again, I've noticed that the past 10 years or so, it's been kind of trending in that same direction that I saw when I lived back in Japan a long time ago. I don't know if you guys feel the same way, where things are a little bit more, at least for relationships. I don't know if they felt that they're a little bit more casual than they used to be, and a little less committed. You guys can correct me if I'm wrong, but that's what I kind of took away from all of things from the past 10 years. Tell me what you guys think about that. If that's an incorrect conclusion, then please correct me if I'm wrong, because that's what I see a lot, at least these days. But uh, here, if you guys have an opinion, please, you guys are more than welcome to. I'll show you how it kind of works out. It's pretty interesting, actually. This was in 2019. So I'll bring up this graph here. Put this up here. This is what's interesting about what statistics can show you. So if you go to like Korea, like South Korea, then South Korea has the world's worst birth rate. So if you're talking about total births per woman in South Korea, you could say it's zero point 0.9 births per woman. Now, replacement rate for people here, if you're talking about replacement rate for people here is going to be 2.1. That's replacement rate. So if you want to replace two parents with two new children who would take over for, say, the next generation, that's pretty much how it works. So that means that if you're at 0.9, well, you're much more below the 2.1 threshold, meaning you're going to be losing population literally every year. All right, so year upon year. That's what also happens in Japan as well. Is Japan's 1.4, so you can see there 1.4 in terms of a replacement rate. It happens to be significantly lower than the replacement rate here. However, if we look, let me look here. The United Kingdom below replacement rate, actually at 1.6. And then here we get the United States. Now we talk about the U.S. here. The U.S. here actually just a touch above at 1.7. So the U.S., if it continues down this path here, actually is losing population in terms of having children, in terms of replacing this set of parents here every single year. So it's rather interesting to see that that doesn't happen overnight. That happened over a long period of time, and that could be due to, again, different trends and whatnot, and how people think. But it's very interesting to hear the opinion there. You can see exactly how things work out in that regard. All right. In any case, I digress. More importantly here, let's go back to our handout for just a moment. Let's go back to our question, excuse me, for just a moment. Now, according to our handout here, let me just bring up the handout. We have a mean here in this case. Now, our mean here is equal to the population proportion. That's what we have here. The mean here is the population proportion. All right, so let's not forget that's the sample mean, sample mean, sample proportion, whatever you want to call it, mean slash sample proportion. Sorry. Gotta remember that I often say this too often. So, okay, now the question is, what is the population proportion according to our problem? What is the population proportion according to our problem here? So let's go back to the book. So taking a look at 17 here, what is P going to equal to here in this instance? What do we get here? What do you guys think? What is P equal to? What do you guys think? What do you guys think here? Give me a guess in the chat. What do you think P will be here in this instance? That's true. That's true, Hadi. It is my second stream. I got one more after this one. But it's the same class. What do you think P is equal to here, guys? What is the population proportion according to this? It says, according to a study, 39% of adult Americans believe that marriage is now obsolete. Alright, guys. I'll wait for your answer. If you guys aren't going to answer, I'm just going to wait. You guys know how it works. $39. Is that how we express percentages, Jake? How would I express a percentage, Jake? So I would say 39 would be fine. But I want to express the percentage how. Because you're on the right track there. How do I express 39%? There you go. 0.39. That's correct. That's exactly what we're going to do here. I'm going to do 0.39. Okay, so this is going to be our P here. This is going to be very important. This is effectively our mean. All right, this is our mean here. This is what we're going to use. All right. Now, how is it going to work here within this context? Let's talk about this for a second here. Now, I will guide you through this one here specifically. All right, so we are going to be using Normalcdf if we want to find the probability of less than 38%. Okay, we're going to be using Normalcdf, which we'll do together on the calculator. Now, compared to what we did on Tuesday, if you remember when we did like less than, okay, we used like -1e to the 99, we did that and stuff like that. Well, in this case, we're dealing with percentages. So because we're dealing with percentages, we only care about between two percentages. That is from 0% to 100%. That's it, right? When we talk about percentages, we only care about from 0 to 100. So if I'm talking about less than 38% here, like I am in this particular problem, instead of having -1e to the 99, I'm going to have 0 here instead as my lower value. So again, go back to our, oops, sorry, that's what's wrong one. Second, to go back to Normalcdf. Remember, we have a lower here. We have 0. Then we go up to 38%, because we want 38% or less here. So we're going to use 0.38 as our next value here in this case. All right. Then we put in our mean here of 0.39. And now, the last number here, you have to be pretty careful about this one here, but at least writing it out is not so hard. And that is, if we go back to the handout here for just a second, we want to put in the standard deviation. We're going to put in p times 1 minus p over n. So we're going to put the square root of 0.39 times 1 minus 0.39. And we'll divide that by the square root of the sample size, which is 500. Do that. All right. Okay, questions about that so far? Hopefully that's not too bad. I'll erase this and drag it. Okay. All right, what I want you to do next, everyone, is I want everybody to take out their calculator here, because we're going to go through these button presses here together once again. Please type "got it" in the chat. Once you have your calculator in front of you. Make sure everybody's got their calculator in front of them, because we're going to go through this carefully together, okay? Got it? Okay. All right. Okay. So, let's go through this carefully here. All right? So, first things first, we're going to hit second and the vars key. So, second and the vars key. Okay. Okay, she almost got it. Good. Second and the vars key. We're going to go to Normalcdf. Okay? We get Normalcdf. Okay, so that's what we're going to use here. All right, now if you have the old school calculator, that's perfectly fine. Okay, even if you have the new school calculator, that's fine. If you have the old school calculator, of course, follow exactly what I have up here. But what I would like you to do here is, if you have the old school calculator, please stop after 0.39. I want to show you how to enter in this last number here, okay? Because we need to be really super careful about that standard deviation. So let's be careful about that, okay? If we're going to enter in it at once, you need to be careful about the formatting. So I'm going to go through that very carefully here in just a second. All right, so let's put in the first three numbers here, which are easy: 0, 0.38, and 0.39. Those are simple. All right, shouldn't require too much effort. Now, the last part here is going to require a little bit of effort, and you need to do a little bit of formatting here. So again, please follow along. All right, first things first, let's put in the square root here. All right, so we put the square root, and as you can see there on the square root, it already comes with a parenthesis attached to it. Whether you have an old school or new school calculator, this is what it's going to look like. Now, the next thing that we're going to do here is, if you see how this is kind of set, it says, okay, we want to put in 0.39 times 1 minus 0.39 and divide that all by 500, and then we want to take the square root of all those guys. So what we're going to do here first is we're going to go ahead and put in another left parenthesis, like so. All right, we're going to go ahead and put 0.39. We're going to multiply that. We're going to put another left parenthesis here. Okay. Of 1 minus 0.39. We're going to close that parenthesis. And then we'll close that parenthesis like so. We'll have two right parentheses like so. So this first one goes with just 1 minus 0.39, because we want to subtract that first. And then this does the 0.39 times 1 minus 0.39. Then we're going to divide, hit the division key, in this case 500, since that's our sample size. And then you specifically do need to put this in. You do need to put in a right parenthesis here, so that way you take the square root of the whole thing. Even if you have the old school calculator here, if you forget this right parenthesis, then it's not going to come out to the correct answer. So you need a right parenthesis, and if you have the old school calculator here, add another right parenthesis after that. So you should have like two right parentheses if you have a old school calculator that looks just like so. All right, and then we'll hit paste for that. Okay, so if you have the new school calculator, it'll look something like this. You notice that this whole square root is underneath all this stuff here. Okay, and then we'll go ahead and hit enter. The answer that we should get here is going to be specifically 0.3233. All right, type yes in the chat if you got this exact answer. I want to be sure everybody put this in correctly in the calculator. Please type yes in the chat if you got this answer. This is very important, so even for the ones who don't speak too much, I need you guys to be on the same page here. Okay, Chioma has it. Juan, what about you? Juan, Julian? Did you get this same answer? Make sure everybody's got it. All right, Juan got it. All right, what about you, Julian? Are you okay with this or no? Did we mix up somewhere? I got it. Okay, perfect. All right. Okay. All right. So that's how we get the first one here. All right. Let's try another one here. All right. Let's try another one. All right. So we can see here. All right. Right. I need to do letter B. Almost forgot. All right. All right. The next one here. Let's do letter C. Sorry. Let's do letter C. Letter C, what is the probability in a random sample of adult Americans between 40 and 45% believe that marriage is obsolete? So the probability of between 40 to 45%. All right. So now the question is, we're going to be using Normalcdf here. All right. What numbers are we going to use for this one here? I want you to type this in the chat here. What numbers are we going to use for this example underneath Normalcdf? All right, point 0.4, 0.45, 0.39, and the standard deviation. Okay, very good, Chioma. That's correct. All right, so that's exactly what we're going to put in here. I understand you don't want to put all the standard deviation stuff in. All right, so we're going to 0.4, 0.45, and we're going to keep the mean and standard deviation, just like from the first part here, exactly the same. Again, we still have a 500 sample size here, so that didn't change. If the sample size does change, then we would change this last part here. All right. And there we go. That's what we have here. And does anybody have an answer for me? What do we get? Do it here. Second in bars. I use 0.40, 0.45. All right. Hopefully we got this answer here. 0.3203. All right. All right, very good. Okay. Let's take a good look here at the next one. Actually, before I do that, any questions? Any questions so far? Is it not 3204? Let me check, Julian. No, because we have a 4 next to the 3 there. So we would keep it the same. So it's 3203, Julian. All right. All right. Let's take a look at another one. Let's take a look at letter D. All right, let's take a look at letter D. Now, it says, would it be unusual for a random sample of 500 adult Americans to result in 210 or more who believe marriage is obsolete? Okay, first and foremost here, let's at least review one thing here. What does unusual mean? What does unusual mean? Remember, what was that metric there? What did unusual mean again? All right, less than 0.05. That's right, Jake. All right, very good. All right, so less than 0.05 is going to be unusual. So that's our base metric that we want to have here. All right, nice. Okay, so what's the trick behind this problem here? If we need to, of course, at the end, we're going to make that comparison to that metric there to see if it's unusual. Now it says, we asked the question here, do you think marriage is obsolete? And let's say 210 or more thought, yes, it is. Okay, let's say that was the result of our survey that we did. Now, let's see what exactly it's talking about here or asking. In reality, what's this asking you to do? This is asking you to go ahead and take 210 and divide that by 500. It says, all right, maybe 210 or more divided by 500. Now, if we do this out here specifically, we're going to get a decimal here of 0.42. So you can do that on your calculator really quick. Now, what this really asks is 0.42 represents 42%. So in reality, this is talking about the probability of 42% or 0.42 or more, right? So we need to find this specific probability here in order to go ahead and see if it indeed is unusual or not, okay? We don't know yet, but that's what we're going to go ahead and find out. Now, we'll go through this here together as well. Now, to serve as a friendly reminder for this one here specifically, we're again still going to be using Normalcdf. However, in this case, it's going to be a little different because now we're not doing, say, 38% or below like the first example, where we went from 0 to 38%. In this case, we're going from 0 to 42%. Or not 0 to 42, we go 42% all the way up to 100%, excuse me. So, remember, we're going to go as low as 0% and we're going to go as high as 100%, all right? So what that means is that our lower value here will be 0.42. And our upper value here will be 1. 1 standing for 100%. Remember, we're not going to 1e to the 99 here. So again, we're not using minus infinity or positive infinity. We're just going between 0 and 1 here since we're only working with percentages in this particular section. Okay, when we talk about proportions, it's only percentages that we care about. And of course, the mean and standard deviation here will be exactly the same as it was in the previous two examples. Okay, because again, our sample size didn't change. We still have a random sample of 500 adult Americans. So in this case here, we're okay. All right, so this again will be 0.39 times 1 minus 0.39. And we'll divide that by the sample size given to us here, which is still 500. Okay, so what I do want you to understand here is, yeah, we're gonna see if we get something below 0.05. Yes, let's see if it's unusual. But also importantly here is that we just stop at 1 if we're just going like, say, 42% or more here. All right, so let's enter this into the calculator here. We'll hit second in bars. Go to Normalcdf. We'll do 0.42. We'll do 1. Keep the others the same. So we do get a probability here of 0.0845. All right, so 0.0845 is going to be our Normalcdf here for this particular example. And so is this unusual? Well, I think we all know that the answer is no, not unusual. All right. Any questions about that? Nope. Okay, pretty easy. All right, good, good. Let's see which other one I want to do here. That's pretty simple. All right, let's look at, I guess we'll look at that next one then. All right, so let's look at 18. We'll do one more example here. So 18's on kind of 2 pages here, so. All right, 18. According to a creditcard.com, 29% of adults do not own a credit card. All right. All right. Suppose a random sample of let's see. Let's go with the other one here. Sorry. Let's look at letter B. So 29% say no, I don't have a credit card. So that's fine. Okay. So let's go look at letter B here. What is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So we're given a sample size here specifically of 500. Okay. And we want to find the probability of more than 30%. So we have all the information here on the screen. Okay. 29% do not own a credit card. What's the probability that more than 30% of the 500 looked at do not own a credit card? I'll just look at 29% period. Again, that's what P is equal to here. 29%, or, of course, looking at its other counterpart. I guess I should say this. I'll give you a hint for this one. Remember that if we say 29%, of course, that means P is equal to 0.29. So what would I enter in the calculator here? All right. We're going to use Normalcdf, by the way. What numbers are we going to use here? More than 30%. Oops, that's not the right function. There we go. What numbers do we want to enter in here? All right, Shioma, what's the standard deviation? All right, this time I'm going to ask you what the standard deviation is. What is the standard deviation? I'll agree with the first three numbers there for sure. 0.31, 0.29, 100% true. Tell me how I would write out the standard deviation. This is important that you guys need to know how to not only write it out on a paper, but you need to write it out on your calculator as well. How do I write out the standard deviation? All right, very good. All right, so here we're gonna have, again, we're gonna get 0.3, 1. Oh, well, it'd be helpful if I could write that properly. 0.3, 1, 0.29, and the square root of 0.29 times 1 minus 0.29 all over 500. Okay, let's go ahead and take a look here, and let's enter this in carefully. So put the square root key, hit that left parenthesis. We'll put 0.29, another left parenthesis, times key, and then another left parenthesis. 1 minus 0.29, right parenthesis, another right parenthesis, and divide by 500, and then close those parentheses. Okay. Alright, and then we'll paste it in. Alright, and let's see what we get here. We get 0.3111. All right. Good stuff. Good stuff. All right, let's do one last one here. Let's do D. All right, D says, would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? Okay, so 125 or fewer. So that's what we're trying to find out here. What kind of probability are we trying to find here? What probability are we trying to find here? Would it be unusual for a random sample of 500 adults to result in 125 or fewer? Probability of what? What's 125 out of 500 there? What's that going to equal? Where did this happen?
No relief in sight with...
Where is that? I don't know where that is. Less than 25%. Okay. So, okay, less than 25%. All right. Where is that exactly? All right. Good. All right. So, what numbers are we going to use here? We're going to use Normalcdf. All right. I'll wait till you guys enter an answer here. Oh, meanwhile, I'm going to find out where this city actually is. This is a small city on the coast of close to SoCal. Okay, wow. That's pretty expensive, I ain't gonna lie. That's pretty expensive. How can you charge that much? Holy moly. The highest in the nation, wow. Hey. Look at that. While I'm waiting for you guys to tell me what numbers I'm gonna plug in, I'll just show you what I'm looking at here. I mean, look at this. Imagine paying $7.59 a gallon for $7.59 a gallon. That's crazy. $7.59 for unleaded. Yikes. They said premium was $8.50 a gallon in this town. Oof. This article makes me thankful that I have that we have 350 gas now. Holy smokes. That's nuts. Alright guys, I'm waiting on the numbers here. Let's go. Guys, I'll be honest with you, this is where you guys have to participate. I can't, look, I can wait here as long as it takes, but you guys, it's a two-way street. I'm not going to talk the whole time. You guys got to participate too, because I need to know where you guys are at yourselves. If I don't understand that, then nobody's going to understand that. I know that's tough with an online course, but that's just how things work, guys. What numbers are we going to plug in, guys? Come on. Let's do this. Alright. Jake says Normalcdf 0.25.39. I think you're using the previous example there, Jake. What's our, don't forget our P here is not 0.39, but it will be 0.29. Okay, 29% here. So be careful about that, Jake. Just have to be a little careful making sure you make note of the, of P here. We have, I agree with the, hey Ansats, how you doing, my friend? 0.25. It is probability, this is true. We're gonna have 0.29 here. The square root of 0.29 times 1 minus 0.29, all divided by 500. Well, I agree with the last part here. Just change those 0.39s there, Jake, to 0.29s. All right, let's put this in the calculator. Let's see what we get. All right, so here we get 0.25. Am I following a study script? No. I mean, I'm doing the lesson, of course, but this is a class. I mean, yes, but I gotta follow particular sections in order. But I just make up the lectures as they go along. That's pretty much how it works. If I had a script on SOTS, that would be terrible. That's not how I operate. Then I'd be saying the same things over and over again. It'd be like a... It'd be incredibly boring. Alright. 0.0244. Alright. Look, I'm Sots, if I had a robotic voice, be like, this is what you gotta do next. And then you plug in the number here. Man, even if I'm saying this to myself, you know, and I know that this is like, you know, Twitch, you basically like talking to yourself sometimes. Then, yeah, even I'd put myself to sleep if I had to listen to that. You know, my own voice is a great, great way to relax and sleep. Sleep too, let me tell you. If I talk like that anyway. So I say, is this unusual? This is yes, this is yes, it's unusual. Alright. Since it's below. Alright, very good. Okay, any questions about this section here? Any questions? About section, about chapter section 8.2, I should say. There. Okay. All right. Now, that in effect is the end of chapter 8. There's only a couple of sections here in chapter 8. All right, that's effectively the end of chapter 8. Now, for next time, we're going to be doing chapter 9. Okay, so chapter 9 is going to be the next part here that we're going to do. All right, so please be sure. Again, we're going to be using our calculators here for next time, so bring your calculators with you. And again, remember that your test is due next Thursday. So next Thursday, the test and the homework for chapters 5 to 7 will be due. Okay, no extensions, no nothing. Don't bother asking. It's right then and there. But I'll be sending out an email here this weekend just to give you a friendly reminder. Okay, so if you get an email from me, it's just to give you a friendly reminder that it's going to be due. The chapter 5 to 7 test will be due next Thursday at 11:59 p.m. Okay? Okay. So, what I would like you to do is, again, next week, guys, more participation. That is my expectation here for next week. I would like more participation here going forward. It's tough talking by myself, so guys, I need your help as much as I need to reduce my insanity. All right, so feels good, man. All right, everybody. Good job today. All right. I know I ask you tough questions, but this is what hopefully gets you prepared here for the test. So it's not intended to be very harsh on you, but its intention is to hopefully help you understand the material, so it makes your job a lot easier once you actually do the homework and whatnot. All right? Okay, very good. Okay, good job today, everybody. We will come back here on Tuesday, next Tuesday, and we will continue moving forward here with Chapter 9 material. All right, everybody, have yourself an absolutely fantastic weekend. All right, have a good evening. Have a good weekend. I hope everybody has a chance to relax and enjoy. Take care of yourselves. And again, as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right, have a great one, everyone, and we will see y'all later. Take care, everyone. See ya. All right. Lots of projects, I know. Have a good rest of your day, Chimpin. Take care, everyone. All right. Bye. Bye, everybody.